Okay, one other attack on customer data that we should mention, just because this is the kind of attack that is sort of unique to software as a service apps. There's sort of no equivalent to doing this if you're not in the web world, and it's called cross-site request forgery. So here's how it works. Alice, a perfectly legitimate user, logs into Alice's bank account. And remember that this basically means at this point, once Alice is logged in, there is in all probability a cookie that her web browser is storing. And on any further request to that same site, that cookie is going to be sent back. Because Alice has done whatever she's supposed to do to log into the site, very likely something about the cookie's value cues the bank that she's logged in and can do things, right? So that part's important. Now, maybe in a different tab or even a different browser window, Alice goes to some evil site, and the page that is served by that site contains something like this. For example, an image that is allegedly supposed to be served from bank.com, but is the page that contains Alice's account information. And it doesn't have to be an image. It can also be a tag that would load some JavaScript code, or it can be some JavaScript code that makes an API request against bank.com. But the important thing about all of these is that you've got a page making a third-party request. And because the browser knows, oh, the request is to bank.com, I should include the cookie. That legitimizes the request, right? So if there is an HTTP request that could result in downloading or revealing some sensitive information on Alice's part, it is possible for a third-party site to, in an evil manner, take advantage of the fact that Alice's browser is already storing a cookie for that site, right? And notice what makes this attack so insidious is the attacker's site doesn't have to compromise Alice's computer in order to do this. It's just relying on the web browser's existing normal behavior that when it doesn't get to a remote site, it will automatically include any cookies that are appropriate for that remote site. And so because that request is accompanied by a valid cookie, the reply may very well contain information that was only available because Alice was properly logged in. So now evil.com has possibly harvested some sensitive information from Alice's main bank account screen or something like that. Now, one question is, if you look at the HTTP request headers, one of the fields that is allowed to be part of an HTTP request is called referrer. And that field is supposed to be the page from which this request originated. So my question to you is, could your server, the bank server, I suppose, check the referrer field in the HTTP request headers? And if it doesn't look like it's originally from the bank, could it just use the referrer field to reject the request? Would that be a valid way for the bank server to protect itself against this kind of attack? And if yes, why is it good enough? And if no, why is it not good enough? It all boils down to you can't trust anybody, right? The answer is that, okay, well, if you just need to put an HTTP referrer in, then whoever is constructing the malicious requests can just construct a request that has the right value for referrer, and now we're done, right? So, and again, what's the higher order lesson here? You can't trust anything that comes from the user. You have to assume that anything that comes from the user could be coming from an evil user. So looking at the HTTP request headers is not reliable because you can just construct them. So what can you actually do to prevent this kind of attack? One thing you can do that is relatively recent is that there is a new attribute that you're allowed to set on cookies called same site. And this assumes that the user's browser is relatively recent enough that it observes this value. Basically, if you set same site to strict when your server is serving a cookie, what that means is the browser should only provide this cookie if the referring request also comes from the same site. So in other words, if a request is coming from a different site, and that can be verified actually, right? Checking the HTTP referrer header is bogus, but you can have the browser not include it. The browser certainly knows that evil.com is not the same as bank.com. And so if the browser observes same site, it knows that even if evil.com is making an embedded request to bank.com, it should not include the bank.com cookies because those cookies included a same site attribute. Another way to do it, which is arguably even more secure and does not depend on the user's browser correctly observing same site, is including something called a nonce. A nonce is basically a value that is used only once. And Rails has a very nice way to do this by putting csurf meta tags as a tag in whatever your top level layout is. What this does is any place where there is a form submission or something like that, in addition to whatever form fields you have specified, there will be an additional form field that includes a hidden value, which is essentially a random number. And so if someone tries to submit the form, Rails is able to check whether the random number hidden field included with that form submission matches the most recently served random number when the page went out. So essentially, you're essentially putting a watermark on the page that serves the form, and you're refusing to accept the submission of the form unless the watermarks match. And then each time a new page is served, Rails will recycle a new random number. So this basically prevents what's also called a replay attack, where somehow the evil site is able to observe your post request with accompanied by the right cookie. Now essentially tries to do a verbatim copy of your post request, but it won't work because now the random number won't match anymore. The random number can only be used once. Okay. So again, this is an example of something that on the one hand is a type of attack that really is unique to SaaS-based services. There's no equivalent of this in a command line app or in shrink wrap software, but the framework provides an almost zero maintenance way to avoid it, which is essentially putting one line in your top level application layout so that each time a new view is generated, it includes a random number, and putting one line in your controller basically saying, be suspicious of any request where those random numbers don't match up. So that's CSRF, or cross-site request forgery.